Okay, systems of linear inequalities, tutorial number 1. Let's go. So today we're going to be graphing linear inequalities. So not systems of linear inequalities, just single linear inequalities. All right, so when we look at number 1, we see we have the equation y, or the inequality, y is greater than or equal to negative 3x plus 4. And we're going to pretend, let's pretend that we're really dealing with the line y equal negative 3x plus 4. Well, we know 4 is our y-intercept, so we put that there. Negative 3 is our slope, so we go down 3 over 1. And then we're going to stop. So we're going to use this to find 2 points. And then we're going to stop. So we're going to find our 2 points, and we're going to stop, and we're going to say, wait a minute, we're not really drawing a line. This isn't an equal sign. It says y is greater than or equal to this line. Now, when we hear ourselves saying greater than or equal to, it does mean that this inequality, this shading we're going to do, is going to include a solid line through these 2 points. Okay, that's a squiggly line, isn't it? So when we see this line underneath the greater than sign, and we hear ourselves saying greater than or equal to, that means the solution that we're about to graph includes the line. So we can use a solid line through the 2 points. All right, we also say y is greater than this line. And it either could be equal to this line or it could be greater than this line. So how are we going to do our shading? What we're going to do is we're going to put our pencil or pen, marker, whatever you're using, exactly on the y-intercept. I don't know if you can see. I'm trying to make the y-intercept bigger. But I'm going to put my point on the y-intercept. And I'm going to say to myself, what's greater than this line? What's greater than this y-intercept looking at the y-axis? Well, if the y-intercept's on 4, then I know going up to 5 and 6 is greater than. So that tells me shade up above the line. So obviously we can't shade all above the line, right? We can't, but that's really, this inequality means this line and everything greater. We could even extend our line and extend our shading to show that. So instead of graphing the line, we are now graphing a linear inequality. All right, so let's do the same thing but with a different problem. First step is going to be, let's pretend that we have a line here. We're going to get our 2 points, and then we're going to stop. We're going to get our y-intercept, which is negative 5. And then we're going to get our slope, which is up 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Get our 2 points, and then we stop. Because we're not really in an equation, are we? Nope. We're in an inequality, and it says y is less than this line. Ooh, can y be equal to the line? Now, y, when we look at equations and inequalities, y is standing for our answer. You know, x is the input, y is the output. So our answer has to be less than the line that we would make if we join these 2 points. So we can't use a solid line this time. We have to use a dashed line or a dotted line because y is not equal to this line, right? We don't see that line underneath. It's less than this line. So to find out where we should shade, if y is less than this line, I'm going to put my pen or pencil or whatever I have in my hand. I'm going to put the point on the y-intercept, and I'm going to say, what's less than negative 5 on the y-axis? Well, all the numbers going down the y-axis are going to be less than that, which tells me my shading is down from the line. Okay, so hopefully you're catching on that the only new thing about today is deciding whether to use a solid or a dotted line to connect our 2 dots and where to shade. So let's look at this next problem. We've got y is greater than negative 4. Okay, I know what the line negative 4 looks like. I know I go to my y-axis and I put a dot on the negative 4, and I know that the slope is 0. It's going to be a flat line, but I don't know whether to draw a solid or dotted. What do you think? That's right, we're going to do a dotted. We see y is greater than the line negative 4. It can't be equal to, so we're going to use dashed or dotted, however we want to say it. And then we'll put our pen or pencil on the y-intercept. It says y is greater than -4. Well, I know all the numbers on the y-axis that are greater than -4 are up. So that means I'm going to shade up. So if somebody looked at this drawing or this sketch, they would see that the answer has to be greater than the line y equals 4, or sorry, y equals -4. So y is greater than -4. All right, let's try another one. X is less than or equal to -5. We know that. The line x equals -5, we go to the x-axis, we put a dot on the -5. We know that x equals a number is a straight up and down line. So can we do a solid line or can we do a dashed? Well, we see that x is less than or equal to. So that, because we see that line, that or equal to line, we know we can make a solid line for our line. Now, remember how I always say for the shading, put your pen or pencil on your y-intercept? Well, there's no y-intercept. So this time, we have to put our pen or pencil on our x-intercept and play the same game. We've got to shade so that x is less than or equal to -5. And I think about, well, if I shade to the right, those numbers are all greater than -5. The numbers that are less than -5 are to the left. So I'm going to shade to the left. All right, so hopefully you're catching on. We're going to get lots of practice with this. Let's do a few more. Now we see that we have an inequality that's in standard form. So before we can graph, we cannot do the cover-up method in linear inequalities because then it gets confusing about where to shade. So the first thing we want to do is go ahead and I gave you that box to work in. Go ahead and rewrite the problem. So work with me. I want to get y by itself so I know which way to shade and what my y-intercept and slope are. So I'm going to go ahead and subtract the 3x from both sides. And just like in tutorial number 0, what we talked about is writing that -3x first and then the 10 behind it. That's the same thing. -3x plus 10 is the same thing as 10 minus 3x. Just like in your calculator, 10 minus 3 would be the same thing as -3 plus 10. So we can write it either way. And we're writing it this way because it makes it easier to graph by putting the term with the x in it first. All right, we're dividing everything by -2. Oh no, we're dividing an inequality by a negative number. That means that my lesson sign is going to change. Don't forget that. So we have y is greater than. Now see this -3 over -2? We want to keep our slope as a fraction because fractional slopes are the best. We see the rise, we see the run. But I know that when I see a negative over a negative, they're going to cancel each other out, right? If you don't believe me, you can pick up your calculator and hit that fraction button, put -3 in the numerator, -2 in the denominator, then hit enter, and you'll see that it'll give you 3 halves. The negatives cancel each other out. And then 10 divided by -2 in your calculator gives you a -5. And now that we've rearranged our inequality that was in standard form into this form where we can see the y-intercept and the slope, it's just easier to graph, right? So our first point that we're going to graph is our -5. And then we're going to use our slope up 3, 1, 2, 3 over 2. We have our 2 points. We have to stop. We are not just going to mindlessly draw a line that connects those 2 points. We have to stop and say y is greater than this line, not equal to it. So because there's no line underneath the greater than sign, I know I have to use a dashed line to connect these 2 dots. And the second thing I need to do is decide where to shade. Y is greater than this line. I'm going to take my pen or pencil. I'm going to put it exactly on my y-intercept. That's why I'm drawing the y-intercept extra big. And I'm going to say y has to be greater than this y-intercept. So where are the numbers that are greater than -5 on the y-axis? That's right, the numbers that are moving up. So I'm going to shade up above the line. All right. I shouldn't be quite so, there we go, make my shading a little bit better. All right, let's try one more. I think that's it. Oh, no, that's not it. All right, let's try one more. Same thing, we're given an inequality in standard form. We want to rearrange things so that y is by itself. And the way we rearrange is the same every single time. We're going to get rid of the x term from the left side. we're going to make sure we put the x term first, and then the leftover number second. Then I'm going to divide both sides, all terms, so both sides, but all terms by -3. Oh no, we divided by a negative. We're going to flip that inequality sign. Once again, same thing here, -5 divided by -3. We don't want to change that to a decimal. That would make it more difficult to graph. We want to keep it as a fraction, but that negative over negative actually cancels out. So end up with 5/3 x. Then -15 divided by -3 gives you a +5. So once again, after we rearrange, we're going to use that information to graph. Oh no, when I put my y-intercept as 5 and my slope is up 5/3, I have to make a choice. I can extend my graph. Now I can't because I don't have enough room on this smartboard, but I could, if I was on paper, extend my graph so I could go up 5/3. But there's also a trick. If you run out of room moving up, you can do the opposite of your slope moving down. So you know how we would go up 5 to the right 3? Well, let's do the opposite. Let's go down 5, 1, 2, 3, 4, 5, and to the left 3. When you do the opposite of your slope, instead of going up and to the right, if you go down and to the left, you still end up with a line that has the slope of 5/3. All right, so can I use a solid line to connect these two dots? Absolutely. All right, let's do the shading. Y is greater than or equal to this line. So we're going to put our pen or pencil on the y-intercept, and we're going to say our y-intercept is 5. Looking at the y-axis, where are the numbers on the y-axis that are bigger than 5? That's right, they're the numbers that are going up. So therefore, I'm shading up above my line. Now, I'm going to tell you something. If you don't do that little thing where you put your pen or pencil on the y-intercept, you might start shading incorrectly. Because just looking at the x-axis, the numbers that are bigger on the x-axis, we would be shading to the right, right? We don't care about looking at the x-axis unless, like our last, one of our last problems, we have something like x is greater than 4. All right, now we're going to have a little fun doing this backwards. What if you see an inequality? It says write the equation. Really? Oops. Write the inequality, right? We can't write the equation because it's not a line, it's an inequality. So the first thing I want to look at is this dotted red line. And I know that the line, if it weren't dotted, would be x equals 4, right? And the shading is greater than 4. So instead of x equals 4, the whole thing together is x is greater than 4. Now, if there were a solid line instead of a dashed line, I would include the solid line underneath the greater than sign. I have a feeling that I made the same mistake. Write the equation. No! Write the inequality. What was I thinking? Okay. So here we go. I'm going to look at the line first. I'm going to pretend that it's solid. This is just like what we did in writing equations of lines, right? We thought about the y equals mx plus b form, and we see that our b is -2, so we know that that's -2. We find another corner point. Oh, there's lots of them because our slope is up 1/1. So y equals 1x. I could write 1x, or I could write y equals x minus 2. Either way, if you were taking a standardized test, you would see it as y equals x minus 2. But wait a minute, it's not really a line. We're looking at the whole thing, the whole inequality. And we say to ourselves, first of all, I can't even put the equal sign because it's a dashed line. And where's the shading? Well, I go to my y-intercept and I see that the shading is up. And up means greater than. So this whole inequality graph is y is greater than the line x minus 2. So see how that works going backwards? It's just like the stuff we did when we were writing equations of lines. All right, so I know that on your sheet, it probably says write the equation. Gosh darn it, slash through there. Write the inequality. What was I thinking? But that's okay. I can make mistakes and then correct them just like you can. We are human, that's what we do. All right, so once again, we're going to do the y equals mx plus b. And we look and we see that our b is 5. And that, let's find another corner point. Our slope is up 2 over 1, but it's negative, right? If I wrote my name on it, woo, going downhill. So my slope is a negative 2x. Now, if it were the line, that would be the answer. And thank goodness this time, finally, we have a solid line. So we know we can have that line underneath our greater than or less than. Now, is this shading greater than or less than? Let's put our pen on our y-intercept. Is this shading up? Yep. And up means greater than. So this inequality, this whole picture, is y is greater than or equal to the line negative 2x plus 5. All right, write the inequality. All right, so here we go. I see this line, and I know that if it were a solid line, this would be what? Y equals negative 4. Now, it's not solid, so I can't do a line, but whatever. That's where I start. I pretend that it's a line. And then I'm looking at the shading. I put my pen or pencil on the y-intercept. I see that the shading is up. Man, all this shading has been up. Why have we not have a less than one? Sorry about that. The variety should be a little bit different here. Another mistake I made. Oh no. Okay, so y, the shading, the answer is greater than the line negative 4. All right, so hopefully that gave you an idea, because I do believe that was the last one. Hopefully that gave you the idea of what we're getting into when we talk about systems of inequalities. First, we have to look at single inequalities and see that they're very similar to graphing lines and to writing the equations of lines, but there's a little added extra, whether the line should be solid or dashed, and there's shading either up or down from the line. All right, thanks for joining me. Have fun practicing.